Okay, so we're going to look at solving equations that involve the variable and the exponent. And there's a lot of different kinds of equations and a lot of maybe different techniques or things you can do to solve them. And so the way I present it may not necessarily be the only way to solve it. So you may have other techniques, but I also want you to think about maybe what are the most efficient ways to solve that, and also without a calculator. So again, some of it might be review, some of it might be brand new to you. So kind of go through this video and these examples, and if you know how to solve it, then great. You could maybe fast forward that and check your work. Or if you need an explanation, then go back and revisit. So one basic technique of solving exponential equations is try to get the same base. So I'm noticing there's just a 2 to the x, but then I'm also noticing that that 16, that 16 could be written as a power of 2. So what I'm going to do is rewrite that as a power of 2 and try to write this as an exponential only like base equation. So 2 to the x would stay, but 16 is 2 to the 4th power. So that is to the x plus 2 power. But when you have an exponent raised to an exponent, you can multiply. So I can get 2 to the x equals 2 to the 4x plus 8. And so here, once our bases are the same, right? So we both have base 2. Since the bases are equal, that means the exponents have to also be equal. And a misconception might be like, oh, you're dividing both sides by 2, or you're really not, right? Because you're just realizing that if this is a base 2 and this is a base 2 and it's an equal statement, then the exponents must also be equal to each other in order to maintain that that equal statement. So then I could just come right down and say, oh, okay, so x equals 4x plus 8. And then we can subtract to solve for x. Negative 3x equals 8. So x equals negative 8/3. So again, looking for the same base or a common base. In the next couple of examples, very similar. 1/9 and 27 are both powers of 3. Because 1/9 is a number less than 1, it could be a negative exponent. So 3 to the negative 2. And 27 is 3 cubed. So that is raised to the negative x plus 4 power. So again, once you have the same base, so base 3, right? Then the exponents must be equal to each other. So I know that negative 2 must equal the quantity 3 times negative x plus 4. Or negative 2 equals negative 3x plus 12. So now, again, solving, we can subtract 12 to the other side. So negative 14 equals negative 3x. So x is equal to a positive 14/3. Okay. And then, again, nothing wrong or different or should be anything to worry about for e as our base. So again, raising a power to a power, that just multiplies, and this is already by itself. So since we're the same base, right, since everything is base e, so then I know that their exponents must be equal to each other. So the quantity, there we go, x squared plus 8x should equal 3 times 2, 6x. Now be careful, you want to make sure you try to solve this quadratic by setting equal to 0. Don't divide by an x because you've lost a solution. So I can subtract 6x. So x squared plus 2x is equal to 0. And that allows me to factor and use the zero product property. So x could be 0 or it could be negative 2. Okay. Again, we should be recognizing that the next problem can be written in all powers of 3. 9 is 3 squared. So that's raised to the 2x power. 27 is 3 cubed. And that's being raised to the x squared power. And then 3 is just the negative 1 power. So again, like when we're raising a power to a power, we multiply. So that would be 4x. But because I'm multiplying the bases, you would add the exponents. So plus 3x squared equals that negative 1. again, all of the bases are 3s, right? 3, 3, 3. And you would be adding, just to kind of recap. So you, like, to combine these, you would have added them to, added the exponents together. So you have 4x plus 3x squareds of the 3s. So now I can go ahead and solve this. I would set it equal to 0. So I'm just going to add 1. I'm going to add this 1 to their side and hope to factor. If not, complete the square or quadratic formula. Let's see, but factoring 1 and 1, that gives me an x, plus 3x is 4x. Yeah, so I get two answers. X is equal to negative 1/3, or x is equal to negative 1. Okay. Now, the idea of getting like bases kind of is the basis, pun intended, for numbers 5 and 6. So for 5 and 6, you're not really solving for x. You're manipulating maybe one side of the equation to make it look like what you're looking for. Notice you're not looking for x, you're looking for 2 to the negative x. So my thought would be, let's realize that, well, wait a minute, 4 is the same thing as 2 squared. So it was like 2 to the, right, and then to the x. So it's like 2 to the x equals 6, right? Again, like 4 is the same thing as 2 squared. And if that were raised to the x, you would have multiplied. So whether it's 2 times x or x times 2, think about this for a second. Like that, these are all equivalent. And so again, what I'm trying to do is isolate 2 to the x. So what I can think about is doing the 1/2 power to both sides, which is really like, the square root power. So if I think about, I'll use red here. So if I raise this side, I thought I picked red. Maybe I didn't quite select it. There we go. If I raise this side to the 1/2 power and raise this side to the 1/2 power, so we're doing the same power both sides, the 1/2 and the 2 cancel, so you just get 2 to the x equals 6 to the 1/2 power. So we're getting close. We just need to introduce the -1 sign. So what I can do is I can raise both sides to the -1 power. Raise that side to the -1 power. So in essence, we're trying to create this. So that is 2 to the -x. And then whatever you do to one side, as long as you maintain the other, then then you can figure out what the equivalency would be. So 2 to the -1/2. So I would accept this as an answer, but we should also realize that the 1/2 power means it's a square root. And the fact that it's a negative exponent says put that root in the denominator. So this is another equivalency. And if you rationalize it, it could be √6/6. So that's another equivalency. So, I mean, honestly, I would accept any of the three answers, right? I would accept, this answer, I would accept this answer, and I would accept this answer. And you should feel comfortable, again, looking at those equivalencies. Okay, so and then the last example on this particular video, same idea. Think about, here's your given. Now create 5 to the -3x. So, the reason I'm picking 5 is because that's the base of 25, right? There's a factor of 5 that we can express. So 25 is the same thing as 5 squared to the x power. And if you want to rewrite 27 as 3 cubed, it might help with your calculations. I don't know. And so, again, trying to create 5x, or at least the x here. So 5 to the x squared equals 3 cubed. So we could try to isolate x. So we could raise both sides to the 1/2 power, because raising both sides to the 1/2 power would cancel this outside 2, because you just would have multiplied. So we raise this to the 1/2 power. So those cancel. So that is simply 5, to the x equals 3 to the 3/2 power. Now we just need to get a -3. So I could raise both sides to the -3 power. I could raise this side to the -3 power, because that would introduce that -3x. So then I raise this to the -3 power. So then I could get 5 to the -3x is equal to 3 to the -9/2 power. And again, because you're multiplying, right? You multiply it in. Now, what does this mean? Well, again, thinking about what the negative does, it makes it a value in the denominator. And then the part of the exponent that's like in a fraction, that's this right here, that 2, that's the index of the root. And so I could think about that as a square root. So it's 1 over the square root, because the 2 would be there. And without a value, we assume it's a square root. So the square root of 3 to the 9th power. So, that's a pretty large number. So, I would accept, I would accept this answer. I would accept this answer. But I would also accept this answer. It just, whatever you find that is an equivalent to that particular value. Okay, so again, some of that might be review, and that's great. And so hopefully then it looks familiar, and you're able to tackle certain questions that will have that particular, particular strategy to solve.